welcome you all. First lecture in the lecture series of the subject of business mathematics. And today, this lecture will be covered the first topic, that is number systems of number system. First of all, I would like to explain under this session, that means the topic, our topic is number system. So under that, I would like to explain these subtopics like what is the natural number, integers, rational numbers, irrational numbers, real numbers, prime numbers, even numbers, and odd numbers. So when I move to the learning outcomes of this session, that means after completion of this session, you should be able to get very good knowledge. That means to get the understanding regarding the number system. That means so you should be able to explain different type of numbers, and you should be able to analyze its different components of different numbers in the number system. So then when we move to the first introduction part of this session. So we know, right? So we know the numbers, right? Numbers, when we can divide or we can categorize under the different type. So to understand, this is very important thing because to get the good knowledge regarding this subject, that means to get the good knowledge of business mathematics for business subject, right? So you have to first to get the clear understanding what are these different type of numbers, because this is basically your understanding regarding this type of numbers. It is more important to understand all the other topics or subject matters or subject topics in this course module. And when I try to start in your subtopic of this topic, first the first number type, right? First number type is natural numbers, right? First number type is when we divide in the numbers different under the different categories. Among them, first we can understand the first type of number is natural numbers. So what is this natural numbers mean? Normally we know natural numbers are, first already we know natural numbers are a part of the number system, right? That means the one category under the number system. So it is including all the positive numbers from 1 to infinity. So we can say natural numbers are including all the positive numbers from 1 to infinity. That is the important, because also natural numbers are also called counting numbers. Natural numbers are also called counting numbers. Why? Because they do not include zero or negative numbers. They do not include zero or negative numbers, minus numbers. So they are a part of real numbers, including only the positive integers. That is more important. Only the positive integers. That is more important, positive integers. But remember, not zero, fractions, decimals, and negative numbers not included in the natural numbers. So therefore, we can define, right? Just we can say what is the natural number this way. Natural numbers refers to a set of all the whole numbers excluding zero, right? This is exclude. We have to exclude zero and also the minus L. So then these numbers are significantly used in our day-to-day activities and in speaking, right? So we use those things, those numbers. So we see numbers everywhere around us. For counting objective, representing or something, or exchanging money, right? For measuring the any other thing like the temperature, when we tell in time, right, etc. For all these things, we need numbers. So these numbers that are used for counting counting objects are called natural numbers. As an example, we can say, while we can counting objects, we can say 5 books or 5 bottles. And we can say 5 cup of tea, or we can say 5 tables, right? 10 tables, so on. So that means we need this number to when we counting, while we counting. So counting numbers are the natural numbers. So further, we can then very clearly, right? Very clearly, simply, we can define these natural numbers as, or natural numbers are the numbers that are used for counting and they are a part of real numbers also. So the set of natural numbers include only the positive integer. As an example, we can say 1, 2, 3, 4, 5 until infinity, right? Infinity. So, so to understand further what is this natural number, just see this example. Just try to understand this example. When I say, right, when I give in the different numbers like this, right, you can see -1, 0, 3, half, and 5. Right? So when I ask from you, identify the natural numbers among these given numbers. Right? What are the natural numbers among this given number set? Then we know normally we can say set of numbers when we put in this bracket, right? It's like this bracket. When we put in the bracket like this, then we can say set of numbers. This is the number set thing. Now, when we consider in the -1, that is negative number. -1 is a negative number. So it is not a natural number. Right? This is not the natural number because it is -1. And also 0 is not the counting number. Then it is also not the natural number. Right? And when I move to the half, then right, when I move to the half, so half being a fractional number. It is the fractional number. So it is also not the natural number. Right? So then therefore, among the given number set, natural numbers are there are only two natural numbers, 3 and 5. Only 3 and 5 are the natural numbers because 3 and 5 are the only the numbers we can use to and the whole number. Therefore, like you can understand, right, natural numbers, understand it very clearly. So then, therefore, I would like to move to the next type of numbers, next number type, that is whole numbers. Second type of number is whole numbers. So then what is this whole numbers mean? What is this whole numbers mean? Whole numbers are a set of numbers including all natural numbers and 0, including all natural numbers and 0. So they are a part of real numbers that do not include fractions, decimals, or negative numbers. And counting numbers are also considered as whole numbers. Right? Counting numbers also we considered as whole numbers. So shall we just try to understand further in detail regarding these whole numbers? We know the natural number, the whole numbers, right? What is the whole number? So we can say natural numbers along with 0 are referred to as whole numbers, including 0. When including 0 to the natural numbers, then it becomes whole numbers. So we know that natural numbers refers to a set of counting numbers starting from 1, 2, 3, 4 and so on. So in simple words, whole numbers are set of numbers without fractions, decimals, or even negative integers. So it is a collection of positive integers and 0. Right? Just when we put in the 0 into the natural numbers, then it becomes the whole numbers. So it is a collection of positive integers and 0, remember. Or we can say that whole numbers are the set of non-negative integers, right? Non-negative integers. And further, we can simply say whole numbers. When we define in whole numbers, simply we can say whole numbers are the set of natural numbers along with the number 0. The set of whole numbers in mathematics is given as this way, right? So I will show you. Set of whole numbers in mathematics given as 0, 1, 2, 3, 3, 4 up to infinite number. And also we use notation as a W to show the normally we use, right? It can be changed, but most of the time we use W for showing the whole numbers. Here are some, yes, I will give some facts about whole numbers which will help you understand them better. What are they? All natural numbers are whole numbers. Is it okay? Yes. All natural numbers are whole numbers. And all counting numbers are whole numbers. Is it also correct? And another fact is all positive integers, including 0, are whole numbers. Right? And further we can say all whole numbers are real numbers. So then we know what is the smallest whole number. We know smallest whole number is 0. 0 is the smallest whole number because whole numbers is starting from 0, right? Or starting from 0. So 0 is the number that lies between the positive and negative numbers on the number line, you know. So although 0 carries no value, but it is used as the placeholder. So 0 is the neither positive. 0 is neither a positive number nor a negative number. We know that, right? You know it's very clearly. So further then, up to now we understood two different number types. But first one is the natural number we understood first. Then second, this is this one, that is the whole numbers. So according to the discussed definition, we can understand that every whole number other than 0 is a natural number. Also, every natural number is a whole number. So, the set of natural numbers is a part of set of whole numbers or a subset of whole numbers. I will explain you to that one this way, right? You can, I think, I will explain for you that one with this diagram, right? Okay. So just give me 1 second. Yeah, right. Okay. When I draw this like this square, so that is the when we show in the Venn diagram, we put this one and okay. Yes, when I put this way, then this a small circle. Inside the small circle, we can say it should be the natural numbers. Right? Natural numbers 1, 2, 3, 4, 5, 6 until up to the infinity. Right? Then whole numbers become here 0. Right? 0 and 1, 2, 3 other whole numbers in here. That is the subset. Okay. So then this second circle we can define as the whole number. First one is the natural number. Right. So then when we showing it as this as a Venn diagram, right? You need to understand the natural number is subset of the whole number. Right? Whole number. And so then the difference between whole numbers and natural numbers, you can understand very clearly. Right? So what's the then difference? So whole numbers, the set of whole numbers is, we use W and it's starting 0, 1, 2 like this. And set of natural numbers, normally we use the notation as a n, and it's start from 1, 2, 3 up to the infinite number, right? And also the difference is the smallest whole number is 0, but smallest natural number is 1. Smallest natural number is 1. And another differentiation we can see in among these two, between these two number types, every natural number is a whole number, right? Every natural number is a whole number, And every whole number is a natural number except excepting the zero. Excepting zero. Right? Zero නැතුව තමයි ඒක අපිට කියන්න පුළුවන් වෙන්නේ. And further whole numbers, whole numbers we can represent on the number line, right? Number line, I will explain that one also in the under the next category, that is integers. Anyway, keep in your mind the set of natural numbers and the set of whole numbers can be shown in the number line, right? All the positive integers or the integers on the positive integers or the integers on the right hand side of the zero representing the natural numbers, whereas all the positive integers along with zero although represent the whole numbers. Both set of numbers can be represented on the number line. So anyway, I will explain how we can draw and how we can show these numbers in the number line under the next type of number type. Right? So then, can I move to the next type of number type? That is integers. Okay. Yes, that is integers. So, yes, yeah, integers. Integers, right? So what does that mean? What does it mean, integers? Integers, normally we know the integers include positive numbers, negative numbers, and zero. So we know normally the word integer is a Latin word which means whole or intact. So this means integers do not include fractions or decimals, right? So let me explain more about integers, right? That means the definition of integers and other important facts according to the fact regarding the integers. So first, what is integers? Then integers include all whole numbers and negative numbers. All whole numbers plus negative numbers. So this means if we include negative numbers along with whole numbers, we form a set of integers. So therefore, we can define, or definition for the integers is, an integer is a number with no decimal or fraction part, and it includes negative and positive numbers, including also the zero, including zero. So a few examples of integers are, shall I write down here? -5, that is the integer, and 0 also integer, -10 also integer. So just because when I put in the -10, just I need to start it first. When I move to the least to highest. So and -10 is the integer, -5 is the integer, -1 is the integer, 0 is the integer, 1 is the integer, right? 2 integer, 3, 5 likewise, right? And also we can say any large number, positive or negative, we know that is the integer. And so a set of integers which is represented as the 0 as the set of integers which is represented as Z, right? It includes, when we use the Z to represent that integers, right? So most of the time we use Z as the notation for integers. So when it is become the what we call set, right? Integer set, then we can put here two bracket and minus values, right? And 0 also, and other positive values, right? Like this. So remember, right? So then the set of integers which we represented as Z, then Z include positive numbers. A number is positive if it is greater than 0. You know the example, no? 1, 2, 3, 4. And also the negative numbers it includes. A number is negative if it is less than 0. Right? As an example, you know, -1, -2, -3. Okay. And also 0. It includes 0. 0 is defined as neither a negative number nor a positive number. Right? But remember, 0 is a whole number. Right? So then you can understand that way what is the integers, right? What is the integers? So then up to now, we understood 1, 2, 3, no? Three different type of numbers, right? Number types, 3 different number types, integers, natural numbers, and whole numbers, right? Natural numbers and whole numbers. So when we considering all 3 type of numbers together, right? We can show it this way, right? You can, I think it is, you can see my slide, right? So when now we are talking about the integers, no? When I put in here integer, right? Integers, we can divide these integers different 2 categories. One is negative, right? Negative numbers. Other part we can say that is the whole numbers, right? Positive, but I won't include their 0 that part, so I can write in here whole numbers, right? Whole numbers. Okay. And this whole numbers again we can divide as a 1 is 0, other part is positive numbers, right? So that this one is natural numbers. Natural numbers, right? Here 0, here natural numbers 1, 2, 3, 4, right? So when we start in the bottom, so we know the natural numbers 1, 2, 3, 4. When we add in 0 natural, when we add in 0 to the natural numbers, then those are the whole numbers, right? Now we know the whole numbers also include the 0 and positive numbers. Positive numbers mean the natural numbers, 0 and natural numbers. And when we add into the whole numbers to the negative numbers, then it becomes the integers, right? Whole numbers plus negative numbers, then it is the integers. So then we know integers we can show in our number line, right? We can show integers on number line. So we know the number line, right? The number line is the number line is a visual. The number line is a visual presentation or representation of numbers on a straight line. So this line is used for the comparison of numbers that are placed at equal intervals on an infinity line that extend in both sides, right? Horizontally, both sides. Extends on both sides horizontally, just like other numbers. The set of integers can also represent on the Therefore, a set of integers can also be represented on the number line. I will show you it also, right? You can see that it when this is number line, okay? And in here you can see 0. Remember, in number line, remember all the parts, right? This part should be equal. That means your all intervals, right? Equal interval should be there, right? Equal interval should be there. Therefore, then I put in here -1, same interval, and I want to put, have to put here -2 and same interval, right? And here -3. Next -4, and we can draw it up to the number infinity. And here 1. So remember, same as this equal interval, 1, 2, 3, 4, 5. Okay. So in this number line, this 0 is neither positive nor negative. And this part is negative integers. This part is positive integers. And we know in this number line, right, from left, when we move to the from left to right, it increase the values, right? Increase the values from left to the, when we move to from left to the right. So remember, then we know in this number line, right, positive and integers can be visually represented on the number line. Integers on the number line help in performing arithmetic operations, right? We will learn those things later. So the basic point to keep in mind while placing integers on the number line are as this way, right? So I'll explain you. The numbers on right side always greater than the numbers on left side. Is it okay? The numbers on the right side, right, is always greater than the greater than the numbers on the left side. Positive numbers are placed on the right side of 0. Right side of 0, because they are greater than 0. So negative numbers are placed on left side of 0 because they are smaller than 0. Then 0, which is not positive or negative, is usually kept in the middle, right? So I know this is very easy thing, you know, right? Already you know, but I have explained those things, right, as a reminding. And it is required to understand very clearly, and when we understand it very clearly, different among the number types, different number types, it is required, right? And next, right, we can move to the what is the other type of other number type, that is rational numbers. So in mathematics, a rational number is a type of real number which is in the form of we can write in the form of I'll write it in the form of P divided by Q, where Q is not equal to 0. Remember, Q is not equal to 0, and any fraction with non-zero denominator, you know, this is the denominator. Any fraction with non-zero denominator is a rational number. Some of the examples of rational numbers are I have given here, right? So 1/3 minus 11 divided by 8, right? For more example, as 1 divided 5, 3 divided 4, right? And number 0 is also rational number, right? Number 0 is also rational number. Why? We can represent it in a many form of fraction, as such as we can write 0 divided by 1, 0 divided by 1, 0, 0 divided by 2, 0 divided by 10. Right? So then 0 is the rational number. But remember, right, that's the important thing. But remember, when we divide in the value by the 0, right, that means 1 divided by 0, 2 divided by 0, and 3 divided by 0, etc., right, are not rational numbers, since they give us infinity value, right? Because in here denominator is the 0 value. Denominator is 0 value. So remember, these are not the rational numbers. So therefore, we can explain or we can define, right? We can define or we can describe as a rational number. So rational number in mathematics, we can define as any number which can be represented in the form of P divided by Q, where Q is not equal to 0. Also, we can say that any fraction fits under the category of rational numbers where the denominator and numerator are integers and the denominator is not equal to 0. When the rational number, that means fraction, is divided, right, the result will be in decimal form, which may be either terminate in decimal or the repeat in decimal. I will explain that one also to you, right? So, shall I take, yes, blank page, right? Then I can write in here. So just I will like to remind in that one again, right? Rational numbers. Rational numbers are in the form of P divided by Q, right? P divided by Q, where P and Q can be any integers. P and Q can be any integers, and also Q is not equal to 0. So this means that rational number include natural numbers, whole numbers, integers, fraction of integers, and decimals. Decimal means terminate in decimal and recur in decimals. I'll explain that, right? So give me to explain, right, further rational numbers, right? So the when I further explaining the rational number, the word rational, right? It is rational originated from the word ratio. So rational number are well related to the concept of fraction, which represent the ratios. So in other words, you can say if a number can be expressed as a fraction where both the numerator and denominator are integers, the number is a rational number. So I will write in here, right? So this P divided by Q, this is the rational number, right? This is rational number. How it become rational? This P should be integer and this Q should be non-zero, right? Non-zero integer. Non-zero integer. So shall we take some examples, right? Examples, some example, when I take the 56 number, right? This is rational number. Then so why? So because we know rational number, we have to write as a P divided by Q. So it's okay, no? 56 we can divide as the fraction. 56 divided by 1, right? So we can write it as the fraction. That fraction also the P, right? Integer, 56 integer, and Q also integer, and it is also non-zero integer, right? So then this is rational number, right? When we take in 0, it's also rational number. How? When I divide in by it 1, then it become also 0. Right? And half, it is also rational number. Okay. So square root 16. Whether is it rational or not? Because square root 16 mean what? Number we know 4. Right? So this one also we can write as the fraction. Right? Then it is the rational number. And minus 3 over 4 also rational number. Further, when I write the 0.3, 0.3, yes, why? 0.3 means 3 over 10, right? We can write it as the fraction. First, this 3 is integer, right? And 10 is also the non-zero integer, right? So then it is also rational number. And minus 0.7 also rational. Why? We can write it as the fraction minus 7 over 10. Okay. So these are the rational numbers. And one more thing, right? When we write this one, minus, sorry, 0.14, again 14, again 14, right? We call the recurring number. So then this is also the integer. Sorry, this is also the rational number, because this number we got when we divide in 14 into 99, right? You can check it. And so however, different type of rational numbers we can understand then. So that integers like 0, 0, 2, 0, 1, integers like not the 0, integers like minus 2, right? Minus 1, 0, 1, 2, 3, etc. are rational numbers. And fractions whose numerators and denominators are integers like this one, right? 3 over 7, 6 over 10, minus 6 over 12, right? So it is also the rational numbers. And then remember terminating decimal. Terminating decimal, like when we divide in our fraction, right? Then it's when we get in some decimal values, it's stopped. When we get in some decimal values, stopped likewise. Okay, if our value is this one, 3, 5. Right? That means when we divide into any fraction, we just get the 3 and 5, then it finished, right? So no need then. And also can be 7, 1, 1, 7. Another example, okay? 7, 1, 1, 6, right? Then it finished after the 6 point, right? So then it is also the terminating decimal. Terminating decimal. And when I put in here 9, 7, 6, 8, right? It is also terminating decimal, right? So those decimal values are the rational numbers. And non-terminating decimals with, this is important one, non-terminating decimals with repeating patterns, right? With repeating patterns, that means after the decimal point, such as we can write this way 3, 3, 3, it's also same, right? Or another example 1, 4, 1, 4, 1, 4, same pattern, right? So those type of numbers are the rational numbers, right? So non-terminating decimal values, right? Non-terminating decimal value. So these are properly known as the non-terminating repeated decimals, and it is also the rational numbers. So however, when identifying, right, identifying the rational numbers can be easily identified with the help of some characteristic. One is all integers, whole numbers, natural numbers, and fraction with integers are rational numbers. And further, if the decimal form of the number is terminating or recurring, as we explained, as I explained to you earlier, right? Then we know that type of numbers also the rational numbers. And in case, right, the decimal seem to be never ending. Remember, right? Decimal seem to be never ending or non-recurring. End එකකුත් නැහැ, recurring එකකුත් පේන්නේ නැහැ. Then these are called irrational, right? Not the rational. I will explain later. As the opposite of rational, that means irrational numbers, right? So as an example, when yes, square root 5, right? So when you taking the value of this value, right? So we know 2-point value because 2 into 2 4 ne. So the 4 volt sorry 2 point volt right? So 2 when we dividing this one, right? So when we take in the square root value of 5, it become 2 3. You can check it 0 6 7. Anyhow, it is not ending, which is an irrational, right? Not the rational, right? Not ending. So another way to identify the rational number is to see if the numbers can be expressed in the form of, that is the most important one, P and Q, P divided by Q, where P and Q are integers and Q is not equal to the 0. Q is not equal to the 0. Right. So then, anyway, right? So when we taking this, right, as an example, yes, I will write it, right? We require a bit time for that one. Anyway, I want to explain you very clearly, right? So look this one. When I write 9, 2, 3, 0, 1, right? So 0, 7. Again, shall I put another value 6, right? Then again, 9, 2, 3, 0, 7, 6. Right? And next again is starting 9, 2, 3, 0, 7, 6. Right? Further, so as an example, right, is this one rational number, right? So I put here dot, right? That means it is not ending, but there is a pattern, right? You can see the pattern is this one, 0.92076. Again, you start 92077. Again, you start 9207. And again, same pattern. And it's also not repeating that one, right? So then this, we can say this is the rational number because we can understand or we can identify this as the recurring and repeating, right? Recurring and repeating, right? Continuously. This number is, right? This number is recurring and repeating continuous. Therefore, this is a rational number. Okay. And when I take this one, right, you can use, when we use in a calculator, you can take the value in this value, right? Square root 2, right? Is square root 2 is a rational number or not? So first we need to take the value of that one, right? So when I take in the value by using my calculator, right, that value equal to 0.1414213562, right? So which is not ending, and also that is non-terminating, right? And non-recurring decimal. Non-terminating and non-recurring decimal. So therefore, this is not the rational number. Right? This is not the rational number. That means it is an irrational number. We will explain later, right? I will explain later rational number. Next, right? Rational number. And now the thing is, right? So be carefully. You need to understand when you carefully. You need to understand rational numbers, right? Because rational numbers, just we can write it as the fraction, and rational numbers can also be expressed in a decimal form, right? Decimal form. Just we also explain. So this is one of the example, right? 1.1. Is this rational number or not? Yes, this is rational number. Why? This one we can write this way. The number is when we divide in 11 by the 10, then it becomes 1.1. So that is the rational number. We can write it as a fraction. Right? And also remember, right? 1/3, you know, 1/3 also we know 3, 3, 3, 3, same, right? Since 0.333 can be written as the 1/3, we know, right? So therefore, it is rational number. Non-terminating decimals, I mean repeated numbers after the decimal point, are also rational number, right? So further we can say 0, right? Whether is 0 is a rational number? Yes, 0 is a rational number as it can be written as a fraction, right? I'll explain you, right? This can be written as a fraction. 0 අපිට එකෙන් බෙදන්න පුළුවන්, 0 10ෙන් බෙදන්න පුළුවන්, right? So I think that's enough those things enough to understand you to what is the rational numbers. What is the rational numbers? So next, when I move to the when I move to the next type of numbers, yes, irrational numbers, no? Yep. Irrational numbers. So that is the opposite of rational numbers. What is this? Is irrational numbers. Irrational numbers are those real numbers that cannot be represented in the form of ratio. That cannot be represented the form of ratio, like rational. So in other words, those real numbers that are not rational numbers are known as irrational numbers. So you know, right? Irrational numbers are the set of real numbers that cannot be expressed in the form of fractions, right? So we know form of fraction means P, yeah, what is it? P divided by Q, where P and Q are integers. Where P and Q are integers. The denominator Q is not equal to 0. Also, the decimal expansion of an irrational numbers is neither terminating nor repeating. We know, right? But irrational numbers, when we define, irrational numbers are real numbers that cannot be represented as the simple fractions. Likewise, right? Where P and Q are integers and Q is not equal to 0. So it is a contradiction of the rational numbers. So common examples of irrational numbers, you know, right? Some values, right? We know value like 5, right? 5. We know 5 mean 22, the value is 22 divided by 7, no? So anyhow, it's when we take in value 3.141592, yes, not stopping, right? So the decimal value never is stopped at any point. Since the value is 5 is close to the fraction, we know close to the fraction this one, close to the fraction this one, right? Not the real value, correct? Close to this fraction. So we take the value of 5 as the irrational number, right? But note that, right, this 5 is the irrational number, right? Because its real value is not ending, not stopping, right? But when we using this way as 22 divided by 7, right? If we consider this as the number, then it is become the rational number, right? It's become the rational number. But square root 2, that is not the rational number. It is an irrational number, because consider the, right? When we consider in this one, it is also its values. When we take in its value, square root 2, right? When we take in the value for the square root 2, it's equal to 1.414213 and not stopped, right? So further, you know another value, E. This is also we use in our mathematics operations, right? Most of the time, its value also 2.718 is not also stopped, right? So therefore, this type of numbers we used as the we consider as the irrational numbers. So, however, when we talking about further irrational numbers, so properties of irrational numbers normally help us to pick up irrational numbers out of set of real numbers. So some properties, right? I will explain you some properties of irrational numbers. So irrational numbers consist of non-terminating and non-recurring decimal, right? Not the terminating, non-terminating and non-recurring decimal. So these are real numbers only. So when an irrational and a rational number are added, then result of their sum is also the irrational number. For an irrational number x and a rational number y, their result, that means x plus y, should be irrational number. When any irrational numbers multiplied by any non-zero rational number, their product is also an irrational number. But for an irrational number x and a rational number y, their product, we know x into y equal to irrational, right? And for any two irrational numbers, their least common multiply may or may not exceed, right? So anyway, addition, subtraction, multiplication, and division of two irrational numbers may or may not be a rational number. So, however, right? However, finally, we can define irrational numbers this way, right? We know that the irrational numbers are real numbers, only which cannot be expressed in the form of p divided by q fraction, right? Where p and q are integers and also q is not equal to 0. For example, square root 5, square root 3, right, are irrational numbers. On the other hand, the numbers which can be represented in the form of p divided by q, such that p and q are integers and q not equal to 0 are, we know, rational numbers. So finally, I will give you some list of irrational numbers, right? 5 is irrational number, E is irrational number, square root 2 is irrational number, square root 3, square root 5, also square root 7, right? You can check it, right? Non-repeating. So anyway, rational, what is the, when we compare it, when we comparing rational and irrational numbers, so any number which is defined in the form of fraction p divided by q or ratio is called the rational number. This may consist of the numerator and denominator. Q is not equal to 0. Denominator should not equal to 0. So rational number can be whole number or integer, right? And also decimal value is recurring, repeating, and so as this as an example, when we divide in 2 divided by 3, right? We know 0.6, 0.6, 0.6, right? So repeating same one. So it is also the rational number, right? And anyway, irrational number is also opposite of that. So we can understand the difference. So difference between two rational and irrational numbers. So rational numbers expressed in, just I repeat this one is 100 times, right? More than 100 times. It can be expressed in the form of fraction of ratio p divided by q, and q not equal to 0 is the rational number. But irrational number we can define as that way. It cannot be expressed. It cannot be expressed in the form of fraction or ratio. And also the decimal expansion is terminating or non-terminating, but it is recurring or repeating. Then it is the rational number. But the decimal expansion is non-terminating and non-recurring at any point, then it becomes the irrational number, right? So, and also we can give some example for that. So finally, then we have, yes, is it okay? I want to check your slides. Yes, irrational number. Yes. Okay. In here, anyway, this now up to now we have understood the five type of numbers, right? So these numbers we can show in as the Venn diagram, right? As the sets, right? So you can see in my slide, right? Just we can divide it as the irrational and rational, right? First, real numbers we can divide as the rational and irrational numbers. Irrational numbers, again, we can't divide. I have given you some examples. But rational numbers, right? Rational numbers are all type of numbers. That means natural numbers also rational, whole numbers also rational, integer numbers also are rational, right? All the numbers are rational. But some integers, right? Integers included also whole numbers and natural numbers, right? And when we move to the whole numbers, it only included natural numbers. But in the natural numbers, no any other whole integer values, right? Just only the 1, 2, 3 up to positive 1, 2, 3 up to infinity number, right? Up to infinity. So anyway, this final diagram, right? You can see I have given all the type of numbers, right? All type of major type of numbers. And further, right? In addition to that, in here, I think these things is also but just I explaining, right? Shall I first come to the even, right? So even and odd, right? Even and odd numbers are another type of numbers, even and odd. So the integers, right? Integers and integers without a fractional element, and they can be positive, negative, 0. For example, we know -2, -3, -1, 0, 1, 2, 3. So, however, even numbers, when it become even numbers are integers that are divisible by 2. In other words, integers with unit place 0, 2, 4, 6, and 8 are divisible by 2 and are even. When even integers are divided by 2, there is no residual, right? There is no remaining value. That means remainder should be 0. අපි දෙකෙන් බෙදුවාම ඉතුරුවක් නැහැ. But odd numbers, in contrast to the even numbers, are integers that are not divisible by 2. At their unit place, they have 1, 3, 5, 7, 9. Like I said, when we divide an odd numbers by 2, you get 1 as a remainder, right? So even numbers have potential